Hi guys, welcome back to Worms Maths Academy. For those of you who've watched the channel a bit, can you let your friends know that I'll be starting the Methods and Specialist courses hopefully in the next few weeks so that they can start learning before next year to get a head start. So that'll be on YouTube, so don't forget to tell them to like and subscribe and they'll be able to get a head start on Year 12. Okay, this is the second half of the Year 12, Unit 3 for Special Maths Exam 2. I have actually done this first question before because one of my students asked me, like, what the hell was it going on about? So I've got a function d, f of x is 2 arcsine x squared minus 2. We know we can just sketch our function. It's probably the easiest thing to do. So it's arcsine, it's been multiplied by 2 from the x-axis. So it's obviously going to be further away than what it usually is. Let's have a look. Okay, so I'll just zoom, initialize. Now the problem is with this, I think what most people would do is they'd think it goes up to 2.7 or something like that, like something that they can see on the calculator. But what we can do, you can just grab the function, go out to the main, paste it, highlight, and to find the range, we just go calculation, fmin. Okay, so my lowest value is negative pi, and it occurs when x equals 0. And then the same thing, but this time use calculation fmax. Okay, and that occurs at, actually we can do this as exact. Okay, so our minimum is negative pi and our maximum is pi, and we go between negative root 2 and root 2 inclusive. So x is an element of, we could say d. d is an element of negative root 2 to root 2, and f of x is an element of negative pi to pi. Is that right? Yes, it was. Okay, so that sort of makes it easier for us to graph. Negative 3.14. Root 2 is, was it root 2 or 2 root 2? Because it's just root 2. Okay. Oh, I'm thinking of root 2 on 2, which is 0.707. So it's 1.414 and then 3 pi, 3.14. So it's going to be about there. And likewise for the other side, negative 1.4, 3.14. We also know when it's 0, we're going to get, when x is 0, we're going to get sine inverse of, when x is 0, negative 1, negative pi. That doesn't seem right, does it? Now, x-intercept is negative 1, and when x equals 1, what sine inverse of 0 is 0? Okay, started off well. Negative 1 and 1. So here we know this is root 2 pi, negative root 2 pi. We know this is negative 1, 0, and this is 1, 0. Our graph looks like it goes down like that. And then it's the same on the other side. Not like that. Bloody hell. That looks reasonable. Okay, and our lowest value is 0, negative pi. Sketch the graph labeling endpoints and the y-intercept with their coordinates. Okay. F dash of x for x is greater than 0. Give your answer in the form that. So, I don't think I defined that, but let's copy it. Go out to main. Define. Okay, and then we can do d dx of f of x given x is greater than 0. And then do the same thing because the next question was less than. So greater than it's 4, less than it's negative 4. Express your answer in the form, so f dash of x given x is greater than 0 is 4 on root 2 minus x squared. That makes sense because it's got a positive gradient. F dash of x given x is less than 0 is negative 4 on root 2 minus x squared. Okay, the derivative of f dash of x can be expressed in the form f dash of x equals g of x over its maximal domain. Find the maximal domain of f dash. So if it's f dash, well, it's not going to be defined at the endpoints, but it's also not going to be defined at 0, and that's because it's a cusp, like it's a sharp point. So we know that it'll be defined from negative root 2 to root 2 with the exception of 0, because it can't be defined at that point. We know the limit doesn't exist from both sides. Find g of x, expressing your answer in a piecewise function. Okay, so g of x is, well, we know the top is it's 4 for x is 0 is less than, not equal to, x, which is less than root 2. And then we know that it's negative 4 for 0, negative root 2 is less than x, which is less than 0. Okay, sketch the graph of g of x on the axis below. So root 2 is 1.4, so let's say that's here. It's 4, 4, looks like that, 0. And then negative 1.4, negative 4, so about there to there. Not exactly rocket science. I don't know what the aim of this question was. And I flipped to the next page and then went, oh, there's nothing there. So that's it for question 1. Yeah, who knows? Okay, state the center in the form xy, where x, y are real numbers, and state the radius of the circle given by this. Okay, so we know it's been moved 1 to the right and 2 up. So x minus 1. Oh, it doesn't say to find the equation. State the center in the form xy. So 1, 2. And radius is, of course, 2. Okay, by expressing the circle given by that in Cartesian form, show the circle has the same center and radius given by that. Okay, so we've got z plus 1, so I'm going to rewrite that as x plus 1 plus yi is equal to root 2 x plus y minus I, which we know is the square root of x plus 1 squared plus y squared. It's equal to the root 2 of x squared plus y minus 1 squared. Okay, now we can get rid of the square roots if we square both sides, and we get x squared plus 2x plus 1 plus y squared is equal to 2x squared, because that, plus 2y squared minus 4y, and then plus 2. Now we want to get it in circle form, so let's bring everything to the right hand side except for the numbers, bring them to the left. So get negative 1 is equal to x squared, that and that's negative 1, that and that is x squared on the right hand side, plus y squared on the right hand side minus 2x minus 4y. Of course, we've got to complete the square then, so x squared minus 2x plus 4 plus y squared minus 4y plus 4 squared, half it and square it. Ah, that wasn't 4. If I halve that and square it, I get plus 1. If I halve that and square it, I get plus 4. Okay, so if we bring it to the other side, what? We're going to end up with a negative on the other side. So, I think I'll bug it up something here. You idiot. I usually just complete the square quickly, which I'm going to do now so I don't stuff it up. So x minus 2x squared minus 2x plus 1, because I've added 1 on, I've got a minus 1. I'm not doing it the quick way, I'm just doing it the other way. Y squared minus 4y plus 4 minus 4. Now, minus 1 plus 4 is going to give me 4 on this side, because when I add 1 to that, that goes to 0. Probably shouldn't cross it out though, because it won't make sense. Okay, so we get 4 on one side. This can be written as x minus 1 squared plus this can be written as y minus 2 squared. So it's a circle with a center of 1, 2 and a radius root 4, which is 2. Okay, graph the circle given by that on the Argand diagram. So our center is going to be at 1, 2, 1, 2, and it's going to go left 2 and right 2. Come on. This thing's supposed to pick up when you do a circle. What? Never seen anything like it before. Okay. Okay. Turn it into a circle. Move it over to here. Okay, so my center's 1, 2. So I'll say there's 1, 2. And it's got to go up to 4. So that goes up to 4. The center's at 1. Maybe. Okay. I think that's about it. Alright, so labeling the intercepts with the vertical axes. So we've got x squared. If we let x equal 0, we get y minus 2 squared is equal to 3. Because when I bring that 1 to the other side, I get 3. So y equals 2 plus or minus root 3. So that's going to be 2 minus, 0, 0, 2 minus root 3, and then 0, 2 plus root 3, and labeling vertical axis. Okay. Given the line z minus 1, z minus 3 intersects the circle given by z plus 1 in 2 places, draw the line given by that. Okay, so z minus 1 is a point there, and z minus 3 is a point there. So the line that intersects is going to be this. That line is going to be there. That is our perpendicular bisector of those 2 points, which you know that is what the locus of that other thing was. Okay, so that is x equals 2. Okay, find the area of the minor segment enclosed by an arc of the circle given by that and part of the line given by that. Okay, so they want this area in here. There's the center of the circle. If we know that's pi on 3 to there, then we know that's also going to be pi on 3. So we know that this angle in here is 2 pi on 3. Okay, so if that angle in there is 2 pi on 3, our angle at the center is 2 pi on 3. Our radius is 2. Therefore, the area of the minus segment, now it's r squared on 2. The angle in radians, 2 pi on 3, minus sine of 2 pi on 3. That's the area of a segment. Okay, so we're going to get 2 pi on 3 minus sine of 2 pi on 3, 2 pi on 3 minus sine of 2 pi on 3. Okay, 4 pi on 3 minus root 3. So 4 pi on 3 minus root 3. So that's the area of the minus segment. You also know that point there and that point there are going to be the same there and there, so you could use that somehow as well if you wanted to. But if we know that that's pi on 3 and it cuts through the center, then that also has to be pi on 3. So the angle subtended at the center has to be 2 pi on 3, which is kind of nice. Oh, that question's finished. Okay, a half 4x squared minus 1. So let's define that in our CAS, get rid of everything else. A half root 4x squared minus 1. Define as f of x. Let's go into here, get rid of that and put in f of x to make sure we put the right thing in. Have a look at it. Oh, part of the graph. Okay, so it's not the whole graph. Okay, the curve is rotated about the y-axis to form a volume of revolution. That is to model the fountain. Okay, so it's going to be like rotated. So that's 1 root 3 on 2. So negative 1 root 3 on 2 would be here. And that would curve I was going to say it doesn't look right. That's there. That's there. So we're going to rotate this about the axis. Don't like that little bit down the bottom. So that's the solid it's going to form. I just do art. I like colouring in. Okay, show that the volume of the photon is given by, when it is filled to a depth of h meters, is given by that function. Okay, so our volume itself is going to be that function. So we want y in terms of x, and we want to integrate from y is 0 up until h. So our volume is pi from 0 to h. Now we've got to get that function, because it's in terms of, we've got to get it in terms of, what do we have to get it in terms of? X squared. So we've got y equals a half root 4x squared minus 1, was it? Okay, so I'm going to get 2y squared plus 1 on 4. 2y squared on 1 plus 4. So 4y squared on 4 plus 1 on 4. Okay, so x squared dy, which is pi, 0 to h. 4y, no, it's just y squared, plus 1/4 dy. Okay, so that's our function. What the hell is wrong with this stupid thing? So let's integrate it. So I'm going to get pi y cubed on 3 plus y on 4 between h and 0. Of course, we're going to get pi h cubed on 3 plus h on 4. Okay, we're going to take it at 4, so pi on 4, 4h cubed on 3 plus h. That's our volume. Find that when it's filled to half of its volume. Okay, so let's say V of h. Find the depth of the water when it's half of its volume. So we can work out what its volume is because we know its maximum is root 3 on 2. So V of root 3 on 2. Okay, so then we've got to set up a function which is, we'll call it g of x. So what was it? y squared plus 1/4 or minus 1/4? Plus 1/4 plus 1 divided by 4. The integral of that from 0 to, it's so annoying when you have to keep switching back, root 3 on 2. Go. 0 to root 3 divided by 2 dy. Okay, so that's our total volume. So that's root 3 pi on 4. Therefore, find h when v equals root 3 pi on 8, because that's half of it. So we can solve that. Therefore, 0 to h of y squared plus 1/4 dy has to equal root 3 pi on 8. Therefore, h is equal to, okay, so if we do this, we'll call it x. It's got to equal, I think I forgot the pi. Root 3 pi on 43.8. That's got to be a pi at the front. Yeah, there's supposed to be a pi at the front here. Pi times. Oh, this one here equals that divided by 8. And solve for x. Let's give it as a decimal. 1.073. Is that right? Oh, You idiot, you don't need to do that. You just need to find y is h, and we know that our function, we just found our function in terms of h. But even still, I should get the right thing. So if we go back here, where's our function in terms of h? Something that gives our volume. So if we go from there to, let's say, x, pi x on 4. Okay, and then if we set that equal to this, we should get the same answer. Interactive advanced solve for x. 0.59. Why did I get a different answer? 0 to x. That's weird. I don't know why I got a different answer there. What the hell's going on? So from there to there, because I didn't do a pi at the front, times, yeah, 0.5909, is that our answer then? Assuming that I've stuffed nothing up, I think it's 0.5909. Pretty easy to forget those pi's, which is annoying. Okay, we'll go with 0.59. So h equals 0.59, because we got that once we put the pi in. Okay, the fountain is initial empty. A vertical jet of water has a rate of 0.04 cubic meters per second. Fills the fountain. So dV dt is 0.04 meters cubed per second. At the same time, water flows out from the bottom at a rate of dV dt in, dV dt out, equals 0.05 root h. Okay, so we know then dV dt is 0.04 minus 0.05 root h. Can we put that over one thing? 4 minus 5 root h on 100. Okay, show that dh dt, so we've got dv dt, have we've got v in terms of h. Okay, so we know v is equal to, pardon me, pi on 4, 4h cubed on 3, is that right? Plus h, yeah. So dv dh is equal to pi on 4, 4h plus 1. Okay, dh dt is dh dv times dv dt. dh dv is just flipped upside down. So it's going to be 4 on pi 4h plus 1 times 4 minus 5 root h on 100. Okay, so that's going to cancel with that, make that a 25. So dh dt is equal to 4 minus 5 root h on 25 times pi, 25 pi, 4h plus 1, 4h squared. That's because that's squared. Lucky they told us that, otherwise we'll just stuff that up. Okay, so that is dHdt. Find the rate in meters per second correct for displays at which the depth is increasing when the depth is 0.25 meters. So when h equals 2.25, we want to work out what the depth is. So dh dt given 1/4. So 4 minus 5 root x on 25 pi, 4h squared. Okay, 4 minus 5 root x on 25 pi bracket 4x squared plus 1 given x equals 0.25, 0.0153. How many decimal places? 4.0153. Height, I guess it's meters. Meters per second. It is, because it says it in the question. Okay, express the time taken for the depth to reach 0.25 meters as a definite integral and evaluate this integral to the nearest tenth of a second. Okay, so we know time taken. So we know what dHdt is. So dTdH is that upside down. dTdH is 25 pi 4h squared plus 1 on 4 minus 5 root h. So then t will be equal to 0 to the height of a quarter, not a half, 25 pi 4h squared plus 1 on 4 minus 5 root h dh, which is equal to, how annoying is this? What can we do? So we've got that function. We want to flip it. So we can do at the front, go over here. Bloody hell. 1 divided by all of that. Okay, and then we want to integrate that from 0 to 1/4. Sometimes you're just flying blind with this because you're just ish. Okay, 9.8454. Nearest tenth of a second, 9.84, 9.8 seconds. Looks pretty good to me. Okay, after 25 seconds, the depth has risen to 0.4 meters. Using Euler's method with a step size of 5 seconds, find estimates of depth for 30 seconds. Okay, so we know the height at 25 seconds is 0.4, and we want to find the height at 30. So we know our height at 30 is going to be 0.4 plus 5 times dHdt when h equals 0.4. So it was 4 minus 5 root 0.4 on 25 pi 4 times 0.4 squared plus 1, which is, give your answer. Okay, so we want to go back to the other one. This one, oh hang on. What are we trying to find? Depth. So we want to find h. I've got the right function. So we want this one, dh dt, in terms of h. Copy, paste. Okay, and then we want 5 times that. 5 times bracket, all of that, plus 0.4, given x is equal to 0.4. What? Okay, 0.4325. Give your answer in meters correct. Okay, 0.432, so it wouldn't round up, so meters. That makes sense because of the shape. It's sort of, it's going to start off faster and then it's going to get slower, so it makes sense that in the next 5 seconds it's not going to climb that quickly. Okay, how far from the top of the fountain does water is ultimately stable? So the rate of change, dh dt, will equal 0. So I guess it's the top. 4 minus 5 root h is equal to 0 because the bottom doesn't really matter because we're going to times it by 0. So we're going to get 5 root h equals 4 root h equals 4/5. H is equal to 16 on 25. So we want it to 2 decimal places. So that's the height. So height from the top is root 3 on 2 minus 16 on 25, which is 0.226. How many decimal places did it want it to? Come on, let me go back. 0.2 decimal is 0.226, 0.23 meters. Okay, question 4. 2 yachts A and B are competing in a race. Their position vectors are given by that. Find the Cartesian equation of the path for each yacht. Okay, so first one, x of A of t is t plus 1. Therefore, t is equal to x minus 1. Therefore, y is equal to x minus 1 squared plus 2 x minus 1. So y is equal to x minus 1. X minus 1 plus 2, which is y is equal to x minus 1, x plus 1, which is x squared minus 1. X b of t is equal to t squared. So y b is equal to x plus 3. Okay, show that the 2 yachts will not collide if they follow these paths. Okay, so x a of t equals x b of t. That will give me t plus 1 equals t squared. So therefore, x plus 1 equals x squared. Advanced solve. Give me the exact answer. 1 plus or minus root 5 on 2. It's phi, isn't it? T equals 1 plus or minus root 5 on 2. T is greater than 0, therefore T equals 1 plus root 5 on 2. Y of A of 1 plus root 5 on 2 is equal to t squared plus 2t, x squared plus 2x, given x equals that. Simplify. 3 root 5 on 2 plus 5. 3 root 5 plus 5 on 2. 3 root 5 plus 5 on 2. Y of B of 1 plus root 5 on 2 is equal to t squared plus 3, x squared plus 3, given simplify me, root 5 plus 9 on 2, therefore as when t equals 1 plus root 5 on 2, they have the same x, or we could say I component. We'd say as when t equals that, that's the only time they have the same I component. Therefore, so when t equals 1 plus root 5 on 2, this is the only time they have the same I component, but their j component is different. They'll never collide. Okay, find the coordinates of the point where the paths of the two yachts cross. Give your coordinates, correct the 3 decimal places. So, x squared minus 1 is equal to x plus 3. Minus 1 is equal to x plus 3. Solve. And give your answer to, okay, negative 1.56 and 2.56. However, they should be... So x has to be greater than 0, because t has to be greater than 0. However, x is greater than 0. Therefore, we're going to get 2.56, and then the y value is x plus 3. So it's 5.56, and of course it's to 3 decimal places, because I didn't pay attention. Stupid thing, stop. Okay, 2.562. .562, and then 2.562, 5.562. Okay, one of the rules to the race yachts are not allowed to be within 2 kilometers of each other. If this occurs, there is a time penalty for the yacht traveling faster. Okay, for what values of t is A traveling faster than B? Okay, so we want to look at their retrospective speeds. So RA of t. Okay, the first one was t, and then 2t minus t j, and then rb of t is equal to, what was the first bit? T squared and then t squared plus 3. So it's going to be 2ti plus 2tj. Okay, so Ra of t, the magnitude of it is 1 plus, when I square 2t minus 2 squared, Rb of t is 4t squared plus 4t squared. Okay, we want to know when mod of Ra of t is greater than mod of Rb of t. Okay, so square root 1 minus square root 1, was it minus or plus? Why would it be plus? 1 plus 2x plus 2 squared. Is it plus 2 or minus 2? Minus 2. Of course it's. And that's less than. And the other one was 2t squared, all squared. So 4t squared, root 8t squared. 8x squared. Interactive advanced solve. Okay, when x is greater than a half or x is less than 2.5. Oh, we want it to be greater than. We want the speed to be greater than. Other way around. Okay, so for negative 2 is less than t, which is less than 0.5. Okay, so we said negative 2.5, which is less than t, which is less than 0.5. However, t is greater than or equal to 0, so therefore 0 is less than or equal to t, which is less than 0.5. 2.5. Did I just stuff that up? Negative 2.5 to 0. Hang on, have I stuffed the whole thing up? 8x squared. Is it a plus or a minus? It's a plus. So that's a plus. Which means that's a plus. Which means everything's going to change. However, because we've got it in our calc, it's easy to do. So negative 0.5 to 2.5. So negative 0.5 is less than t, which is less than 2.5. So then this is going to be t is greater than 0, so 2.5. Okay, if yacht A does not alter its course, what period of time will yacht A be within 2 kilometers of yacht B? Okay, so we want the magnitude of R of t minus R of B of t to be less than 0.2. Okay, so what's t plus 1 so t plus 1 minus t squared square root t plus 1 minus t squared plus t squared plus 2t minus 2t squared minus t squared plus 3, so it's going to be 2t minus 3. And we want that to be less than 0.2, within 0.2. So it can be less than or equal to. Okay, squared. So x plus 1 minus x squared x plus 1 minus x squared plus 2x minus 3 squared is equal to 0.2. Select all interactive events, solve 1 point. What have I stuffed up here? Is that right? I've done wrong. Is there anything wrong? T plus 1 minus t squared, difference between my I components, t squared 2t minus 3, 2x minus 3 squared, x plus 1 minus x squared, it is the distance. For what period of time will the yacht so is it between those intervals? So that one minus, so that's T1 and T2, and times it by 60. Yeah, so it's between T equals that and T equals that. So if I said less than, it might make more sense. Yeah, so between those 2 points, so if you do one, take away the other, you get the time in hours, but it wants you to give it in terms of minutes. So then we times it by 60, so 4.11. So 4.11 minutes. Where are we up to? T equals 4.1 minutes. Give your answer in minutes. Yep. Luggage in an airport is delivered to its owners via a 15-meter ramp that is inclined at 30 degrees to the horizontal. A 20-kilogram seat placed initially at rest at the top of the ramp slides down the ramp against a resistance of V newtons. So that's V. That's going to be our normal force. Our suitcase is 20G. Okay, by resolving forces parallel to the ramp, write down an equation of motion for the 20 kilogram. Okay, so we've got, that's 30, that's 20. We need to find x. So sine 30 is x on 20G. So x equals 20G sine 30 minus V, and that equals 20A. I think that's it. That's all we've got to do. V newtons per kilogram. So that's 20V. And then that's 20V. Stupid. Okay. Oh, were they all 20? Can't show the magnitude of acceleration as that. Okay, so we divide all through by 20. What's sine of 30? I'm going to get g on 2 minus v is equal to a. Sine of 30 is a half. Oh, yeah, that's right. So a is equal to I should just say divide all by 20, and then a is equal to g minus 2v on 2, common denominator. I hate to show that's when it's bloody obvious. Okay, by expressing a in an appropriate form, find the distance x. Okay, a in an appropriate form, so we've got a v and an a, so I'm thinking v dv dx is equal to g minus 2v on 2. Okay, so I'm going to say 2v on, because I'm multiplying that 2 across, on g minus 2v dv is equal to dx. Okay. As a function, okay, x, so x is equal to minus 2v plus g into 2v, that's negative 1, plus 2v, 2v minus g is g. So we're going to get g so we've got g on g minus 2v minus 1 dv, which is, okay, so if we want the top to have a, bring the g out the front, negative 2, so I've got to put a negative g on 2, so I don't change anything. So I get negative g on 2 log e g minus 2v minus v plus c is equal to x, when x equals 0, v equals 0, because it starts from rest and its displacement 0. So 0 equals negative g on 2 log e of g minus 0 plus c. Therefore, c is equal to g on 2 log e of g. So x is equal to g on 2 log e of g minus g on 2 log e of g minus 2v, and then minus v. Okay, so I've got to bring them together. X is equal to some constant, but we want that now. Need another line. So x is equal to g on 2 log e of g on g minus 2v minus v. But we need that v to be just a v, so divide everything by 2. So get x equals g on 2 log e g on 2 on, we can change it to 4.9 if you want, should make it a bit easier. Okay, so 4.9 log e, if I divide g by 2 I get 4.9, if I divide that by 2 I get 4.9, minus, if I divide that by 2 I just get v, and then minus v. So therefore, C is equal to 4.9, because it's got to be the same for all of them, which it is. And what was the other letter? B is -1. Find the velocity of suit K just before it reaches the end of the ramp. So X is equal to 15. 2 decimal places. Okay, so 4.9 what am I doing? 9 natural log of 4.9 oh, hang on, we want to find, so 4.9, I just rubbed out stuff that I could have used anyway. 4.9 on 4.9 minus X minus X is equal to 15, because that's our displacement. So we want to solve that for X. Okay, so X equals 4.81 meters a second, because it can't be negative. Okay, write down a differential that gives the time taken for the suitcase to reach a speed of 4.5. So what do we know? We know dv dt is that. So dv dt is equal to, because that's the acceleration, g minus 2v on 2. So therefore, t is equal to the integral of 2 on g minus 2v dv from 0 to 4.5. So our time, because it says write down, it gives a time. Find the time taken for the suitcase to reach that. Okay, so we've got the integral of 2 on 9.8 minus 2v between 0 and 4.5. So the integral 0, 4.5 of 2 on 9.8 minus 2x dx, and this will give us the time. So 2.5055 to 2 decimal places, t equals 2.5055, 2.51 seconds. Okay, number 6, we should be just about there. This has taken quite a while. The heights of mature water buffaloes in Australia are known to be normally distributed with a standard deviation of 15 as claiming the maximum. The mean height, okay, 150. To determine whether height and range is selected a random sample of 50. The mean height is 145, a one-tailed statistical test. Mean height of 140 sample, mean height of that, okay. Let X bar denote the mean height of random sample of 50 mature water buffaloes. State suitable, okay. So H0 is that we think that their mean is 150. H1 is that we think that their mean is less than 150. Find the standard deviation of X bar. So the standard deviation of X bar is 15 on root 50, which is 15 on 5 root 2, which is 3 root 2 on 2. Write down an expression for the p-value of the statistical test and evaluate your answer. Correct to, okay, p-value. So the p-value is given by the probability that x is less than 145, given that x bar is given that mu is equal to 150, and that's the probability that z is less than 145 minus 150 on my standard deviation, 3 root 2 on 2. Therefore, the p-value is equal to, so that's going to be negative 10 on 3 root 2. Continuous, norm CDF. Okay, negative infinity, p-value. What the hell am I trying to do? Okay, so lower is negative infinity, 145. Oh, we can just use z. I just worked out z. That's what I meant. What am I trying to work out? Continuous, norm CDF. So negative infinity. My upper is, I just did it again. We just want the probability that z is less than negative 10 on 3 root 2. Okay, 0.0092. Was it right? 4 decimal places. Okay. State with reason whether. Okay. H naught should be rejected at 5% level as 0.0092 is less than 0.05. Hence, the p-value is less than the significance level. So it should be rejected. What's the smallest value of the sample mean that could be observed for H naught to be not rejected? Okay, so if we wanted it to not be rejected, we need the probability that, first we'll find the probability that z is less than c is equal to 0.05, and that's the probability that n is less than, x is less than, stop it, let's just work that out first. So, distribution inverse. Okay, so I want the left-hand side to be 0.05. So that gives us negative 1.6448. So C equals negative 1.6448. So therefore, our mean minus our standard deviation times that. Okay, so our mean is 150. 150 minus that times our standard deviation. That'll tell us the lowest value that we can get. So 3 root 2 on 2, 146.51. Okay, so the smallest value of the sample mean would be I think, what does it say? Correct to 2 decimal places. 0.5107. I mean, if you used, I would think it'd be 156.52 because it has to be greater than 5%. I think if you used 156.51, you'll see. Let's try it. So interactive distribution, continuous, norm CDF. If we went negative infinity up to 146.51, 3 root 2 divided by 2, and then, oops, what did I do there? And that's 150. I think this will be above 5%. No, it's not. What about if I did 2? Then it's above 5. Oh, so it's below. So yeah, I think it should be 152. Because if it's 151, it's actually below. So you wouldn't reject it. But you're right on the borderline. Okay, the true mean height of all water buffaloes is 145. What is the probability that H0 will be accepted at the 5% level of significance? So, if the true mean height was 145, but we want to accept H0, 5% significant. What is the problem? Okay, so the probability that we'd accept H0 would be the probability that X bar is greater than 146.52, given that mu is equal to 150. Because if it's greater than that, then we're going to accept the null hypothesis. So that will give us the probability that H0 will be accepted at the 5% significance level. Okay, so so this value, 146.5, wish I hadn't have gotten rid of all that other stuff before. We'll just use 146.5152. Okay, I think it was actually 517 or 07. Okay, so distribution continuous norm CDF 146.5107 to infinity. So these are all the values that I could get where I would accept the null hypothesis if it was greater than if the value, if our sample mean is greater than 146.51, then that'll mean that we keep the null hypothesis. Well, what did I just do? $146.51. So that's 95%. Oh, given that the mean is 145, that makes more sense. Okay, did I just write 150 here as well? So if the real mean is 145, the chance of me accepting that the null hypothesis is correct is equal to 0.24. So there's a 24% chance, was it 24% chance? Yep, 24% chance that I would accept the null hypothesis even if that the mean is actually 150, there's a 24% chance that I would think that the mean is still 150 based on that sample. So any sample above, with any sample mean above 146.51, and I would keep the null hypothesis. And there's a 24% chance that could happen if the actual mean was 145. So that's what we're trying to get at. Using Zerb's sample mean, 145, 90% confidence interval for the mean height of all mature water buffaloes. Express your values in a confidence interval. Okay, so my confidence interval, so 99, 145. So statistics calc interval, 1 sample Z, confidence level is 99, sigma is 15, X bar, what did it want us to use in this one? 145, and N is 50. Okay, how many decimal places? 1 decimal place. So 139.5 and 150.5. 139.5, 150.5. So using the Zerb sample mean of that, find 90% confidence interval for the mean height of all mature water buffaloes. Express the values in your confidence intervals in centimeters, correct 1 decimal place. Okay, so that's our 99% confidence interval. We would expect, if we got a whole heap of sample means, 99 of those if we got 100 confidence intervals, 99 of them would contain the real population mean, which was 145. But that's our confidence interval based on that sample mean, 139.5 to 150.5. And we're done. So don't forget to tell your friends that I'm going to start the methods and special courses online. So hopefully they can get a head start for next year, and hopefully they can do well on the exams. I hope you did well. Hopefully not as well as my students. No, I'm just kidding. All right, thanks, bye.